Since 1997, Goldenfields Water has been responsible for providing water supply services to several communities in the southwest slopes and riverina regions of New South Wales. With 46,000 customers, Goldenfields Water supplies quality drinking water across an area of 22,526 square kilometres, which includes the local government areas of Bland, Coolaman, Junee and Temora Shires, parts of Cootamundra-Gundagai Regional Council, Hilltops Council and Narendra Shire. Today, we are going to take a closer look at one of Goldenfields Water's main treatment systems, the Jugiong water treatment plant. The Jugiong water treatment plant sources its water from the Murrumbidgee River, but before it is pumped across our network and out of our taps, a lot must happen to the water to treat it. Join us as we take you through the process that your drinking water goes through to ensure all bacteria, viruses and other harmful particles have been removed before it can be consumed by our customers.
Hey Seth, welcome to the Jugiong water treatment plant.
Well, this is a really big water treatment. How much water is stored here?
We treat approximately 12 to 18 megalitres of water every single day to 18,000 customers across our Jugiong supply scheme.
Wow, 18,000?
Yeah, 18,000 people. So that's roughly the same as 5 Olympic swimming pools every single day treated at this plant.
So where do the rest of the Goldenfield Water customers get their water from?
So Goldenfields Waters operates 4 other water supply schemes in 4 different towns, but their water treatment plants are slightly different to the Jugiong water treatment plant in that their water source actually comes from underground water which we obtain through a bore.
A bore? What exactly is a bore?
A bore is basically a natural underground storage facility for water known as aquifers. So we just drill a hole down into the ground to be able to extract that water and pump it up to the surface.
Wow, interesting. Is it safe to drink the groundwater?
You still need to treat groundwater. Generally, groundwater will contain lower amounts of sediments and bacteria as it has been naturally filtered by the Earth's soils and rock. However, it is more likely to have higher concentrations of iron and manganese, which can cause discoloured water for our customers. There are multiple other sources of drinking water, such as surface water, seawater and reclaimed water, all of which require different methods of treatment to remove contaminants. But for today's visit, we're just going to take a closer look at surface water, which is the type of water that we treat here at the Jugiong water treatment plant. Ready to take a closer look?
Sure am.
Let's go! So here we are in the lab, where our 2 full-time water treatment plant operators can monitor the water as it progresses through the 10 stages of treatment. Now the water here that we treat at Jugiong treatment plant is surface water, which we source from the Murrumbidgee River, which is located just at the foot of the treatment plant. Now different types of surface water can include rivers, lakes, streams and dams. The Murrumbidgee River is home to a diverse range of plant and animal life, which generally contaminate the water with particulate matter and pathogens or harmful microorganisms.
What exactly is pathogens and particulate matter?
Particulate matter refers to particles of dust, dirt, sand and sediment that is found in drinking water. They are so tiny that the naked eye wouldn't be able to see them. And pathogens are microorganisms found in raw water that are harmful to human health and may cause diseases.
So to ensure we remove all of the contaminants from the water and make it safe to drink, Goldenfields Water uses a conventional treatment plant, which involves the processes of flocculation, sedimentation, filtration and disinfection to transform the water from this to this. Keen to take a walk around the plant?
Sure am.
Let's go! So here we are, Seth, at stage 1 of the treatment process, extraction. This is where water from the Murrumbidgee River flows into this well, where we extract it up to the treatment process up at the plant.
Cool. So how the water looks in the river now is how it looks up in the treatment plant.
Exactly. There is a large screen over the water well intake, and that just prevents large sticks, twigs and branches from getting caught up in the treatment process in the plant. From here, the water is pumped up to the rapid mix tanks, which is then starts the treatment process. Let's go have a look, shall we?
Yep. Okay, so the water from the river's been pumped here. What happens next?
Yep, so here we are at the rapid mix tanks where we dose a chemical called poly because it's a polymer.
So what does poly do to the water?
So the poly helps bring together all the organic materials such as plant and animal waste. We also add a chemical called aluminium sulfate, or more commonly referred to as alum in this step. Now the alum actually works to bring all the contaminants together to form what we call flock. The flock is so fine and light that the poly then works to create larger and heavier flock, which makes it easier to remove at the next stage of treatment.
Okay, that makes sense. So do they use the same amount of chemical each day?
Good question, Seth. No, the amount of alum added each day will vary depending on the quality of the water, that is, how clean or dirty it is coming out of the river. Now, our water treatment plant operators will conduct multiple jar tests every single day in the lab to help determine what the optimum amount of alum is.
So basically, the required amount of alum depends on the quality of the river.
Spot on, Seth.
And so why are these tanks called the rapid mix?
So the tanks act as the name suggests. They have stirrers inside that provide fast mixing to ensure that the chemicals are well mixed in the water to create a uniform solution. Kind of like giant egg beaters when you bake a cake. Shall we go have a look at the next stage of the process?
Let's go.
Okay, so here we are at the settling tanks where we have flocculation and clarification. After the chemicals have been mixed in the rapid mix tanks, the water enters this settling tank where the majority of the floc will settle to the bottom due to gravity. Hence why it's so important that the floc is as large and as heavy as possible before it leaves the rapid mix tanks.
Okay, so why is it separated by this big wall?
So good question, Seth. This wall basically has one side of the water going through flocculation and the other side is going through clarification. But thinking back to forming large floc in the tanks, we must ensure that all the particles collide with one another so they form really large clumps. But the rapid mix stirs it too quickly and too fast, so the loose clumps actually just break apart. So at the beginning of the tank where the flocculation process occurs, there are these three large paddles that rotate slowly enough to provide mixing whilst ensuring that the particles clump together and don't break apart, causing really large and heavy flocs. Once this process is complete, the water will flow over this wall and into the next stage known as clarification.
That makes sense, but why are these tanks so big?
So engineers design settling tanks quite large so that most of the material settles to the bottom of the tank. By making the tanks really big, it means the settling process can happen more naturally and doesn't require copious amounts of energy to be put into the process. This makes it more sustainable and more cost efficient, while in comparison to other separation technologies. Here you will see a large rake behind me slowly scraping along the bottom of the tank. This pushes all of the material sitting on the bottom of the tank out into the sludge lagoons. So by the end of this stage, we have pretty much removed all contaminants from the water. Let's go take a look at the next stage, shall we?
Let's go.
Here we are at the sludge lagoons where all of the floc that is removed from the settling tanks is discharged to.
Why does it only look like one dam is being used?
Well, we only use one dam at a time so that the second dam can actually dry out, as you can see there. This makes the sludge actually turn into a solid waste, making it easier to be removed and sent to landfill. So if you look below you, Seth, you'll see here the clear water channel, which is actually where we send all of the clarified water from the settling tanks through to the filters. We also dose chlorine at this point to the water.
What does the chlorine do?
Chlorine helps fight any pathogens that might be present in the water. By using the chlorination method, we can disinfect water throughout various stages of the treatment process, and once the water leaves the treatment plant and is being pumped around our network through the pipes, we can always adjust our levels of chlorine to ensure our water is always safe to drink. We are constantly testing the water and have staff members who travel around our region to test water at different towns and communities. Located through our network are what we call rechlorination stations. So basically, we can dose the water with additional levels of chlorine from these stations to ensure we maintain the quality of the water throughout the network.
Wow, so even when it leaves the treatment plant, it still continues to be tested before it reaches our taps.
Spot on, Seth. So we do this to ensure we continue to meet our Australian drinking water guidelines to provide our customers with quality drinking water through their taps. Let's go have a look at filtration.
Filtration is an extremely effective process at removing pathogens and particulate matter that remains in the water after sedimentation. Filtration forces the water through layers of what we call porous media. Porous media can be defined as a solid or a collection of solid bodies that have sufficient space in or around them to enable fluids to pass through or around them. A sponge is an example of a porous material as it has a large number of empty spaces compared to its volume. Other examples include sand, gravel, and coal. Most filters contain layers of these material that the water has to flow through to collect any impurities that still remain in the water. Filters have to be routinely cleaned to maintain optimum performance. This is done by a process known as backwashing.
Here at the Jugiong water treatment plant, we use 6 individual filters that are made up of layers of sand and gravel. To backwash the filters, air is pumped up through the sand and gravel to dislodge any material, and then clean water is passed across the filter beds whilst air continues to scour the sand and gravel to remove all the contaminants that have been captured.
So won't the air blow away the sand? And do you need to refill it?
Good question, Seth. That's a very real possibility. Hence why it's so carefully controlled the amount of air and water that is pumped up through the bed. It's inevitable that some will be lost eventually, but this is pretty minimal. For example, after 30 years of operation, this treatment plant hasn't had its sand or gravel replaced at all.
Wow, so surely the water must be ready to drink.
Nearly, Seth. Only 3 more steps to go. Let's go check out the filter gallery.
So what happens in here, Mitch?
So in the filter gallery, which is really noisy in here, we're taking samples of the water to measure the filter performance and also to determine how much soda ash and fluoride we need to add to the water.
So what soda ash and fluoride do to water? And isn't fluoride the stuff that's in toothpaste?
It sure is. So soda ash is used to raise the pH of the water to make it more basic, and fluoride is used for the same reason it's in toothpaste, for better dental health.
Now, fluoride naturally occurs in water, and so it is only added when necessary. In waters with naturally high fluoride levels, fluoride won't be added. Soda ash is added to help us achieve our target pH range, which is between 7.2 and 7.8. By adding soda ash and making the water neutral rather than acidic, it provides the optimum level for effective disinfection.
So after the water has been treated in the filter gallery, it is sent to the clear water tank here and stored until it needs to be fed down to the pump station for distribution to our customers, making this stage 9 of the water treatment process.
So no further chemicals or testing is required after it leaves the filter gallery?
Almost. On its way to the clear water tank, the water is dosed with chlorine and fluoride to meet the Australian drinking water guidelines. Chlorine is added to kill any remaining pathogens in the water, and from here the chlorine levels are constantly monitored throughout our entire network to ensure the correct concentration levels are maintained to maintain safe drinking water.
Why is it important that levels are constantly monitored?
We refer to the chlorine's concentration levels as a chlorine residual. So basically, if we have a situation where pathogens get into our network at a later date, once the water leaves the treatment plant, we're able to neutralise and deactivate the pathogens so that they don't cause harm to any customers that drink the water.
Wow, who would have thought there was so much involved in getting drinking water? You don't really think about how it gets to your tap, I guess.
Absolutely, and ensuring high quality drinking water doesn't stop there.
Inside this shed is the final stage of the treatment process, the pump station, which distributes the clean drinking water to all the communities Goldenfields Water provides water for within the Jugiong scheme. To reach all these communities, the treated water travels through kilometres of pipeline and other pump stations to reach the storage tanks known as reservoirs. These reservoirs are located throughout our scheme, and you will generally find some of them located on the outskirts of different townships. Goldenfields water staff regularly collect water samples from all of our reservoirs and pump stations out in the field to test different parameters before the water reaches our taps, so customers can rest assured they will always be provided safe drinking water.
Wow, Mitch, it's been a really insightful day.
My pleasure, Seth. Thanks for coming. And remember to always be water conscious. We all have a part to play in saving water.